So here's how this is going to work. And like I said, I think really the best way to see this is through the use of something like SSL. Okay, so, and of course, SSL, TLS really is what we're primarily using, but the same idea still works the same way. All right, so let's say that we have a server, maybe a web server for a bank, Bank of America. And I have a client who's trying to make a secure connection. So that client's going to initiate a secure connection using HTTPS as its protocol, Hypertext Transfer Protocol Secure. And what that secure says is that it tells Bank of America we want to set up a secure connection, so Bank of America needs to send the client the public key. So I'll call this guy the client. We'll be talking about Bank of America as the server. So basically this S says, hey, server, send me your public key. Now remember, there is nothing secret about a public key. Bank of America will happily send them their own public key. So Bank of America comes back with Bank of America's public key. Now, technically, we could go with this public key, and when the client wants to send something secret to Bank of America, it could use Bank of America's public key to do so, and that's true. But then what would Bank of America use to send information to the client? Well, the client doesn't have a public key. There's nobody that's given the client a public key. It may or may not have one. And even if that were the case, each individual message would be encrypted with something different. It's very cumbersome and a lot of overhead. So this is the first step. This is the second step. But here's where things get interesting with SSL. With the third step, the client will generate a symmetric session key. Okay? So this client, specifically the client's web browser, generates a key. We'll say that key is 8439. Now, obviously, it'd be a much longer key, but just for brevity's sake, we're saying that's the symmetric key the client generated. Well, because the client generated it, the client knows the key. It's the one that came up with it. But with symmetric cryptography, the trouble is, how do I get this key to the Bank of America server? The Bank of America server. That's the problem with symmetric cryptography. So what about if the client encrypts the session key with the server's public key? We're encrypting a key within a key. So I've asked Bank of America for their public key. They give it to me. And I take Bank of America's public key and I use that to encrypt the session key that I've just generated. Now, if that session key is encrypted with Bank of America's public, what's the only thing that can decrypt it? Bank of America's private. So what I've done is I've done secure key distribution by using asymmetric cryptography. Why? So that I can get a symmetric key distributed between two parties, and once I have that symmetric key distributed, now I have symmetric data exchange. That's desirable because symmetric cryptography is fast, and we don't know how much data there is to be exchanged. This is a very, very common idea. Asymmetric key exchange, symmetric data exchange. Asymmetric key exchange, symmetric data exchange. And we sometimes refer to that as having a secure channel set up because it's ultimately everything that is transmitted that gets encrypted with the session key. So it's like we're both connected on the same channel and only these two parties know what channel to tune into. That's what's called secure channel. But the idea is I've used asymmetric cryptography to exchange keys, specifically to exchange the session key. Now I can do symmetric data exchange. Very, very common idea with cryptography. Let's use asymmetric to solve the problems that we had, but ultimately what we really want to do is symmetric data exchange. And you can see this best in SSL. Now, we have one more consideration to make with this, but I really want to make sure that this makes sense because, again, such a foundational principle. So asymmetric key exchange, symmetric data exchange. But here's the problem with this. When the client says, hey, Bank of America, I want a secure connection, what's to keep somebody from intercepting that query, stepping in and saying, I'm Bank of America, and here's my key? The answer is, right now, nothing. There's nothing that prevents that because, as you may have noticed, we don't have any built-in authenticity to this. I ask Bank of America for a public key. Somebody comes back and sends me a public key. It could be an impersonator for all I know, and then everything I'm sending to that impersonator is encrypted with their public key. So what I need is, at this step, I need some assurance. I need some authenticity. And here's how that authenticity comes. Prior to Bank of America ever being a web server, okay, Bank of America is deciding, hey, we want to have a web presence 30 years ago or however long ago. What Bank of America did, and really specifically somebody representing the Bank of America web server, went to a company like VeriSign. VeriSign is a CA. And the CA stands for Certificate Authority, okay, a Certificate Authority. And I chose VeriSign because they're very well respected in the industry. Most folks have heard of VeriSign. If you haven't, you may have heard of Thought or Baltimore, Entrust. There are just a bunch of them. But this being the Certificate Authority that most people respect. All right, a representative from Bank of America showed up at the VeriSign office in person, provided them with a driver's license, credit card information, financial information on the bank, credit records, all of that stuff. And they have proved that they are a legitimate organization, Bank of America. In exchange for that, what what VeriSign did, is they gave Bank of America a certificate. Now, what's on that certificate? Well, first of all, the name, Bank of America. And if you've ever connected to a server with a secure connection and you've got an error message saying something like the name on the certificate does not match the name you entered, something's gone wrong with that piece of it. Now, what else is on there? Well, an expiration date, class numbers, because the class of certificate will indicate, hey, this is authorized to be a banking server, whereas another type of certificate may not have that high degree of authorization. A serial number, and the public key. So it's the certificate authority that binds a public and private key pair to the identity of a server. VeriSign says Bank of America is public key 8675309, whatever that might be. But how do I know it really comes from VeriSign? And how do I know that it comes from VeriSign, that it hasn't been modified in transit? We already know the answer to that. How do we know this certificate hasn't been modified? What does VeriSign do before it gives it to Bank of America? It hashes to guarantee the integrity. Well, how do I know it came from VeriSign? What does VeriSign encrypt the hash with? Should encrypt the hash with the certificate authority's private key. If I can decrypt that hash with VeriSign's public key, I know it came from VeriSign. I'll hash the certificate. If my hash matches the hash on there, I know it hasn't been modified. So this just continues to build on the principles we've talked about. Okay? So this happened years ago. Bank of America has a certificate. So when I say, hey, server, send me your public key, Bank of America doesn't just send a string of characters back over the line. Anybody could do that. Instead, what Bank of America does is sends me their certificate. And that certificate, of course, contains their public key. But because it's digitally signed by a trusted authority like VeriSign, I have that guarantee. And let me just say, there are no guarantees in this world other than death and taxes. So when I say guarantee, I mean we get a good, solid, reasonable assurance that that really is Bank of America, because they're able to give me a certificate signed by someone I trust that says, this is Bank of America, and here's their public key. So this is really just building on the ideas that we've talked about. But what makes all of this necessary, or what makes all this possible, is a PKI. public key infrastructure. And that public key infrastructure says we must have a certificate authority. And it's not cheap or easy to set up a series of certificate authorities. There's not just a single VeriSign certificate authority, right? Tons of VeriSign certificate authorities. The process of Bank of America having a means to query the certificate authority at VeriSign and say, hey, I need a certificate. Me as a client having software that understands certificates. Me as a client being able to check and see if Bank of America's certificate has been revoked. And one of the ways that used to be handled is by me contacting the issuing authority and say, hey, can you send me your certificate revocation list? So when you talk about bringing public and private keys in here, in asymmetric cryptography, there's a lot that has to happen. This isn't cheap or easy. You need certificate authorities. You need certificates. You need a way to bind those to users' IDs. You need to have users and applications and protocols that understand certificates. And PKI, public key infrastructure. So it's not easy to make this work. Not to mention the fact that we've got to find some way to make sure the client has VeriSign's public key and all those other certificate authorities. So we've got quite a bit that's going on here that's necessary in order to make this work. Now, we'll refer to VeriSign as a trusted authority. And yeah, VeriSign's well known. They've been in the business for a long time. People know the steps that they go through in order to verify Bank of America's identity before they'd ever give them a certificate. But when we talk about trust, it's actually much more than this. When we talk about trusting VeriSign, what that really means, trust, really means I have the certificate authority's public key. So when I say I trust VeriSign, that means I have VeriSign's public key. And how I got VeriSign's public key was that within my browser, it's automatically been loaded for me. Essentially, I trust VeriSign because Microsoft says, thou shalt trust VeriSign. And as a matter of fact, if we do open up our browser. Okay, so as I mentioned just a minute ago, when we say that we trust a certificate authority, what that really means is that in our web browser, we've essentially been told to trust. And the way, I'll just open up Internet Explorer because that's very commonly used. So again, essentially we trust because Microsoft says to trust. So loaded into our web browser, we have trusted certification authorities. And you can see many of them. There's DigiCert, GoDaddy, of all things, and Thought, and so on. But there's VeriSign. And if I open up that certificate that's automatically populated in my browser, by the way, do you see how the hash algorithm is SHA-1, just like we expect? RSA is an asymmetric algorithm that creates the signature for us. But as I scroll down, not what I wanted to see, there we go. As I scroll down, there's the public key of VeriSign. So that public key is in my web browser. And if this public key is able to decrypt the hash on the certificate, then I know that certificate was issued by VeriSign. If the hash that I produce matches the hash on the certificate, I know it hasn't been modified. So the real meaning of the certificate is that it's signed by a trusted authority. If it was signed by somebody else, that may be a rogue CA or it may not be a reliable one. So essentially what happens is Microsoft says, these are the certificate authorities we deem to be reliable. Well, that's fine, but in a more secure environment, what we would likely do is remove every one of these and only populate them with ones that we feel are trustworthy. This may be shocking, but we may not always trust Microsoft's judgment for security purposes. I'm going to let the reality of that sink in and let the shock and awe settle just for a few minutes. But the bottom line is, anytime you allow things to happen automatically, you give up some control for ease of use. Updates, so very important to keep your system up to date because sometimes these updates push out fraudulent certificate authorities or certificate authorities that have been compromised. Did you know TAR had a compromise last year? They were out of business in a very, very short period of time. So basically, this is a way of pushing out and saying, wait, don't trust these. And you'll also see ones that look legitimate, like Microsoft or Google or whatever, but ultimately they're fraudulent certificates. Now, I'll also mention that within my environment, let's say that I, as an instructor, wanted to set up a web server, and I want all my students to be able to connect in, download the homework securely. Well, I can certainly do that, but the problem with that is, if you're going to be able to connect me securely using SSL or TLS, I need a certificate. We'll go to VeriSign and get a certificate, you say. But the problem with that is, I'm too cheap to go to VeriSign and get a certificate, because a certificate from VeriSign could cost hundreds or even thousands of dollars. Not going to happen for me. So what I could do is I could set up my own certificate authority, and I could issue a certificate to Kelly's web server. Now that's kind of an environment where I vouch for myself, if you know what I mean. This is Kelly's web server because Kelly says it's Kelly's web server. You would never want to do something like that for web-based transactions, but for an internal office environment, why not set up your own PKI? Well, there's overhead with it, but it may save you money over going with VeriSign. It may give you greater control, greater security. So if I do have a certificate authority, and I want you to trust that CA, every web browser has the option where you can import certificates into the web browser, or even better, I can push that out with group policy. And group policy, we'll talk about some this week because it's just a quick, easy way to push out software, to push out certificates or configuration settings. So I can set up an internal PKI. But when somebody tries to connect to that web server, they're going to get a certificate message. A word of caution. We are so desensitized to error messages and warning messages. Often when someone gets a security warning saying, the certificate authority that has signed this certificate is untrusted, or the name on this certificate does not match the name you typed in, most people's thought process goes like this. What is the first button I can click on to make this pesky error message go away so I can hurry up and send my credit card to some unknown stranger on the internet? And that's really what's happening when people go, cancel. I started this business 20 years ago working help desk. Used to drive me crazy. You'd show up at somebody's desk and they'd say, or they'd call you, I'm getting this weird error message. What was it? What did it say? And I'd get my pencil ready to write it down. I don't know. I just clicked on cancel. We're so desensitized to these error messages. Every now and then the error message might actually help you figure out what's going on. But the bottom line is we're allowing our users to become so desensitized. I can't tell you how many times I've seen a network admin say, just cancel that error message, don't worry about it. Well, that's okay, except now the user in their mind thinks, security messages are to be canceled out, we shouldn't worry about them. What they are enforcing and training their employees to do is disregard security messages. That's dangerous. That's a problem. That is a key flaw in the things that we do. Okay, so I've said my piece. That's just my little soapbox I like to get on, because so many times as network admin, for the sake of expediency, we are mistraining or we're poorly training our people. All right, so that's the essential nature of certificates. When a server gives you their public key, you need to know that that server's public key really is legitimate. Who did it come from? Who says that's Bank of America's public key? Why do I trust that? Well, we have trusted certificate authorities. The trust of the certificate is only as good as the trust of the authority. And the trust of the public key is only as good as the trust of the certificate. So all this stuff that we build on with crypto, it just builds and builds and builds. And it's what comes together to make a public key infrastructure. So that is very, very significant. And I would certainly expect several certificate questions on the exam because it is very valid, such an essential piece. One other thing I had mentioned is that, so I go to Bank of America as a client and I say, give me a secure connection. Bank of America comes back and tells me their certificate, or sends me back their certificate. What, as a client, I should do is say, hang on, Bank of America, let me go check and make sure the certificate has not been revoked. Now, I mentioned to you guys earlier a list called the CRIL, the CRL, and that stood for Certificate Revocation List. I want you to know that acronym. I also want you to know the acronym OCSP, Online Certificate Status Protocol. And that's the protocol that streamlines the ability to verify if a certificate has been revoked. And I know I'm writing at the bottom of the board. You may not be able to read my handwriting. So OCSP, Online Certificate Status Protocol. Online Certificate Status Protocol. The whole purpose of this is to make it easier for clients to check whether or not a certificate has been revoked. And that's a configuration setting in your web browser. And for a long time, it was a very cumbersome process. So clients never even checked to see if a certificate has been revoked. It's like if you were to get a speeding ticket and the police officer pulls you over and looks at your driver's license. Just because you have a driver's license doesn't mean it's a valid one. That officer should always go back to the car, call in the driver's license, make sure it hasn't been suspended or revoked. Same idea with certificates. So Online Certificate Status Protocol makes it easier for clients to check and see if the certificate has been revoked or not. Now, that's quite a bit of information with public key infrastructure, certificate authorities, how some of that works. This is something that is testable, certainly, obviously, because we spent a significant amount of time on it. You really want to review this material and make sure that you're solid on it, because so many things that we'll just talk about matter-of-factly moving forward, like Kerberos, or later we will talk about DNSSEC, or go a little further into SSL or whatever. So many things that we do are going to just require that you have an understanding of symmetric versus asymmetric, certificates, public key infrastructure. So I would encourage you before you move forward really to review that section. It's very important, very testable.